All right, so the very first one on here is just like what we've done in the past, right? We would do, do we have to multiply them first, or can I just do a factor tree right from the start? You can go either way. You're both right. Guys, please, Anthony, let me explain things to you, okay? You could do your factor tree right from here. Totally fine. If you want to multiply them, you can. In this case, multiplying them would be easier because you get 81. And what's the square root of 81? It's 9. Do we need the plus minus? It started with the radical. I didn't put it on there. It started with it. I'll be honest with you guys, from here on out, the rest of this chapter, the radicals will be given to you. So you don't have to worry about plus minus from here on out. Okay? So there you go. Yes?
Is there a
Pattern. What do you mean by a pattern? Oh, that's just a fluke. Yeah. All right. This next one. Now, one thing we need to make sure that we're looking at, they have to be the same root. Like, I can't multiply a square root by a cubed root. They're not like terms. Okay, they have to be the same. So here, I can multiply these together. What's 9 times 81? 729. So cubed root of 729. Is that perfect? Yeah, what's the cubed root? It's 9. You're like, wait, this is not hard, right? They'll get harder. You know that, right? It gets harder. All right. They're both fourth roots, so I can multiply. What's 8 times 32? 256. Is there a fourth root? Again, practice with the calculator. Make sure you know what buttons to hit in order for this to happen. Okay, you'd have to hit the 4, second caret, 256, and it's 4. Yeah, 4, math. Is it option 5? All right, what about radical 6 times the cubed root of 12? I can't do anything. Done. I can't do anything with that. I can't do anything with that. They're not the same. I cannot put those together. Okay? All right, so in the very basics of all of this, they have to be the same root in order to actually put them together. Okay? So like that last one, one's a square root, one's a cubed root. I can't do anything with that. All right, here's where things are going to get a little harder because they're not perfect. So one thing I need you guys to get in the habit of is please stop for a minute and look at what root it's asking for. You guys are so trained for square root, square root, square root. Like, not everything's a square root. All right, so like this one is a square root. So let's kind of talk through our process here. Right? This one actually is. So we would do a factor tree. 48 is 2 and 24, 2 and 12, 2 and 6, 2 and 3. And then what would we look for? Pairs. I'm looking for pairs. Why are you looking for pairs? But why am I looking for pairs? You guys ever question that? I love how you guys blindly just follow whatever I tell you. Right, but why pairs? Why not groups of 3? It's a square root. What's the index here? 2. So I'm looking for groups of 2. Yes. Yes. So groups of 2. So there's a group of 2. And there's a group of 2. So we have 4. We have a single radical, 3. But I got some variables to work with. We haven't really done much with the variables. Say that again. 3 divided by 2. Can I take a group of 2 out of that x to the third? Yes, I can. X to the third. Hold on. There's x to the third, right? X, x, x. Groups of 2 come out, right? So groups of 2, they come out as x. And I got one single left over who stays inside. Whoa. Wow. So y to the fourth So there's a group of 2. There's a group of 2. It'd be y. Y squared. Hold on, time out. Yesterday, what did we do? We took 4 and divided it by 2. What's 4 divided by 2? Y squared. Now, let's go back to the whole idea with the x's, because it didn't divide nice, right? So 3 over 2 is 1 1/2. 1x came out. 1x stayed underneath the square root. Cool, right? So if you turn, like whatever you're dividing these, if you would turn it into a mixed number, this is how many come out. So like if this been a 2, you'd have x squared out here. And then whatever the numerator is how many go back inside. That's a 1, so it's x to the first goes back inside. Cool, right? Now, some people struggle with that, so they're like, I would rather write out all of them and circle them in groups. Can you do that? Sure. But what if I give an exponent of like 55? Right? But I mean, that's like the shortcut. So what we learned yesterday with the whole dividing, it still applies. Let's look at the next one. So cubed root of negative 27. Is that pretty? So let's hold off on negative for a minute. So 3 and 9, and 3 and 3. Do you have a group of 3? The cubed root of 27 is 3. You guys know that, right? Group of 3, so it comes out. It is negative because there's a negative inside there. It's not an I because it's an odd root. No I. All right, and then it'd be x to the second. Right? 6 divided by 3 is 2. Or again, if you had 6 x's, groups of 3, you got 2 groups of 3 and none left over. Right, yesterday we talked about dividing it. 6 divided by 3 is 2. It's the same idea. This is just the drawn out visual form of it. Trying to appeal to all the different types of learners in here. All right, how about the next one? 5th root of 128, is it pretty? No? All right. Well, let's do a factor tree. What do you multiply? The 128. I thought you were going to say 5. I panicked for a minute. 64 and 2. What did you say? 4 and 4 and 2. Does it matter? No. So I'll go 8 and 8 just for fun. 4 and 2. 2 and 2. 4 and 2. 2 and 2. Doesn't matter. You end up the same spot no matter how you go. All right. So how many do I need to be in a group? I need 5 of them. So how important is it to cross things off as you go? So 1, 2, 3, 4, 5. So that means I have a 2 on the outside. How many is inside? So what goes in? 4. Yeah, there were 7 of them altogether. So 5 of them came out as a 2. And then the 2 that are left had to go back in as 4. We always multiply them when we put them back in. 3. When we're talking about numbers, whatever numbers are left as singles, we're just going to multiply them together and stick them back in. Like if I had a 3 and a 2, a 6 would go back in. If I had a 4 and a 5, I shouldn't have a 4. If I had a 7 and a 5, I put 35 back in. Right, I know we're used to looking for pairs, but I need 5 of them in order to come out. So what about x's? Can any of those come out? No, I don't have 5 of them to come out. And my y's? 25 divided by 5 is 5. No leftovers, right? Oh, okay. Gotcha. This right here? It's a 5th root. Oh, yeah. All right, guys, question was, why did I put this little 5 right here? Yeah, if I don't put that little 5, meaning fifth root, if I don't put it at all, what do you assume it is? You assume it's a square root, in which case it completely changes everything. I can't tell you how many points students lose on this test because they don't write that index number down. Everything else will be right, and they don't put that index, you lose a point every time you forget it. I know, right? I do it too. I mean, it's just easy to forget about it. Okay, so let's look at the next one. Cubed root of 135, is it pretty? All right, so what do you multiply to get 135? 5 and 27. 3 and 9. 3 and 3. I need how many to come out? I need 3 of them, right? Because it's the cubed root. 1, 2, 3. So what comes out? 3. Singles. Is it just singles anymore? Technically, it's not singles. It's anything that doesn't fit in the group of however many I'm looking for. So I need 3 in my group here. So the 5 is going to come back under. Yep, just like when we did square roots before. All right, and then x to the 5th. So 5 divided by 3 is, try again. Obviously. It's 1 2/3. Painful. We're doing 5 divided by 3, which is 1 2/3. So how many x's come out? 1 and 2 stay underneath. Or again, think about 1, 2, 3, 4, 5. Groups of 3. I have one group of 3 that comes out. The other 2 extras stay inside. Yeah, that's how they kind of work together. Okay, next one. Square root of 80. Not pretty. That's what I was looking for. Not pretty. So 8 and 10. 2 and 4. 2 and 2. 2 and 5. How many do I need to come out? I have to have 2. I have 2 sets of 2, which becomes 4. What do I do with 5? He stays inside. X to the 7th. How many come out? 3. So x cubed. How many stay in? Because again, 7 divided by 2 is 3 1/2. So the 3 comes out, the big 3. The 1 is how many stays in. And then my y is 6 divided by 2. It's 3, so y to the 3rd. And there's none left over. I don't know. That's my honest answer. I don't know. What did you say? It's not going to help you on this. Decimals don't help you at all here. All right, and that last one? 5th root of 96? Not pretty again? What do you multiply to get 96? 16 and 6? It is so funny to me where you people come up with that. Like, in my mind, that is never the first thing I'm trying. That's what I would have done. I went 32 and 3. I just find it interesting where some people like start. I don't know. I don't care. Still end up same spot. How many does it take to come out? 5. Takes 5 of them. 1, 2, 3, 4, 5. All right. So a 2 comes out. What do I do with the 3? Goes back in. 5th root of 3. Let's talk about our variables. So a is 6 over 5, which is 1 1/5. So how many come out? 1. How many stay in? 12th. So 12 over 5, 2 and 2/5. So b squared. And how many b's inside? 2. B squared. Again, would you want to draw out 12 b's? No. Jesse, you probably would. He would draw little bees with like little stingers on them and literal like little bees. They got stripies on them. You don't have legs. Bees? I asked, would you want to draw out 12 bees? Jesse said yes. And I go, yeah, Jesse would probably be drawing 12 of those. Sorry. All right. Okay, so what about a multiplication problem? So let's multiply them and let's see what we got. Real hard, huh? So, what's 7 times 32? Thank you. And then we have x to the 8th. Good. So first step, just go ahead and put it together as 1. And then let's simplify it like we just did. So 4 through to 224, pretty? No? All right. So we'll do factor tree. 7 and 32, because you know that's where I would have started. It's funny. For some of you, it would have been like 2, 2, 2. It don't matter. So 2 and 16, 8 into 4 into 2 into, and it's fun. But what would happen if you don't circle them? Like some people don't circle them. I'm like, how? Oh, you gotta circle them. You stand out. How many do I need to come out? 4. So 1, 2, 3, 4. So I get a 2 on the outside. What goes back in? 14. All right, and then we have our x's. Be x squared on the outside. 8 divided by 4 is just 2. My radical got a little long there. All right, there's a 2 in front and there's a 3 in front. Where do they go? Yeah, you just multiply and they stay in front. All right, so 2 times 3 gives me 6. And then we have cubed root of 6 times 9. 6 times 9. I know, I'm like, what is wrong with you guys? You're my advanced class. X to the 9th, good. Y to the what? 3rd, good. Whoa, shot way up there. All right, cubed root of 54. Not pretty? So no, not pretty. All right. 6 and 9. 2 and 3. 3 and 3. All right, how many does it take to come outside? 3. Takes 3 of them. 1, 2, 3. 3 times 6, because it's already out there. 18. What do I do with this 2? Inside. All right. So let's do my x's. 9 divided by 3 is just x cubed. And it'd just be y. Y to the first. Y to the first. Yeah. So it's nah. How are we doing so far on the multiplying? Not bad. Do we need to do any more examples here? One more? One on your own? Yeah. Actually, why don't you try both of these on your own? All right, let's go ahead and go through them. So this one I already went ahead and multiplied it together, and I did my factor tree on my 2400 just to save some time here. So how many does it take to come out? How many in a group do I need? Just two, because it's a square root. So I got a group of 2's, another group of 2's. I had a group of 5's. So I'm like, I don't have more 2's in there. All right, so we have 20. And then singles, I have a 3 and a 2, so 6. Okay, talking about our variables then. So it'd be 7 divided by 2, which is 3 and a half. So how many come out? X to the third. How many stay in? And X. And then my Y's, 6 divided by 2 is 3. So just Y to the third. Thank you. How'd we do? Good? No? Do you have your factor tree? Okay. And we'll just chalk it up to a basic math error somewhere in there. Are you okay though? I think she's all right. She probably just did a little. She's fine. All right, down here on this one, how many does it take to come out on this one? Three. You have to have 3 of things. Did I hear an 8? So I got a group of 3 2's times 4, Amanda, is 8. There it is. All right, single, we have that 3 that needs to go inside of there. Okay. The 8, I had a group of 2's times the 4 that was already there. Of course you did. All right, and then we have 6 divided by 3, which is 2, so x squared. My y, 7 divided by 3 is 2 and 1/3. Anthony, I'm glad that you can pay attention. So y squared and y. All right, so we okay with multiplication? Ready for me to move into division? Okay. Yes, we have to. I do. I do. So division, just like when we did this with square roots, when I have the radical, I can either move the radical to the whole thing, or we can do them separate, right? Like you can have the radical over the whole fraction, or you can have them separate. They mean the same thing, right? You guys with me? So for problems like these, my personal suggestion to make your life as easy as possible is try to simplify your fraction first. That makes your life so much easier. So on here, does 189 divide by 7? What is 189 divided by 7? Is that a question? Should have been a question because it's wrong. All right. So it's still underneath the cubed root, right? Because I have not touched that at all. But we divided them. That's 27. X to the 7th over x squared is x to the 5th. And then see if I can simplify from there. In this case, I completely eliminated the fraction from the start. So what's the cubed root of 27? It's 3. And then x to the 5th, so 5 divided by 3 is 1 2/3. So how many comes out? How many stays in? 2. You know not all division's that easy, right? Okay, so far though? Okay. All right. Can I simplify this one? 243 divided by 3? Yes, that is 81. say you never would have guessed that? I don't think it was a guess. 24 divided by 3 is 8, and 3 divided by 3 is 1. 81? No? Nothing? It's like you never would have guessed that was 81. I'm like, 24 divided by 3 is 8, and 3 divided by 3 is 1. That's how I do all of my math. You've never, seriously, you guys? The fact that I just did 24 divided by 3 and 3 divided by 3, did you get that? That's long division in my head. It's long division. Mm-hmm. Oh, you guys. All right, what about my x's? What do I have? So where does it go? So it goes on the bottom? X to the fourth? Okay, so simplify your fractions first. Then let's try to clean up the radical stuff. Fourth root of 81? 3. And the fourth root of x to the fourth? It's just x. We're done. Now, the division ones don't get hard unless you get to a point where the radical's still on the bottom. Yes? Let's talk about it. You're kind of right, but you're probably not entirely right. Okay. So let's take a look at this one. So here we go. So we have, oh, this one's an easy one. So what is radical 63 over radical 7? So again, I have not used the radical yet, so it's still 9. The x is going to stay there. And my y's become y squared. So I don't really have a fraction. Square root of 9. Square root of x. Radical x, thank you. Square root of y squared. Y. That one was easy. Yeah. Actually, the next one's not too bad either. Try the next one on your own. All right, so hopefully you divided first. Right, we got 27 x cubed y squared. All right, dividing first. So then what's square root of 27? So it's not pretty, so we do our factor tree. Since we're talking about square roots, I only want groups of 2. So 3 on the outside, 3 on the inside. X cubed, 1 out, 1 in, and just 1 y on the outside. So not too bad. It's the same idea. But here's where things are, let me fast forward you. Let's jump to this one.
First of all, 7 looks like we've already done something like this.
Oh, this is where the notes got different, didn't it? Is this problem on your notes? Number 7. That's all right. Move on. Yeah. So here, guys, on this one, sorry, I opened the Thanksgiving version of these notes instead of the ones I printed for you. Sorry, that's the problem. So here, like this first one, we've done this before, right? We have a radical 5 down here. We can't leave the radical, so what would you do? Multiply top and bottom by radical 5. So we'd get 3 radical 5 over 5, right? We've done this. Now the issue comes on this very next problem. If you can wait like 1 second, you can catch this last part. Now this one, what's the index on this? 2. So how many do you see? 2. I need 3 of them. The bottom's going to be a 2. But just like when you did your factor trees, you needed groups of 3 for cubed roots. If I'm going to get rid of a cubed root off the bottom to rationalize, I need 3 of them. Okay? If I do it to the bottom, you have to do it to the top. So on the top, we have the cubed root of 12 over 2. It's that same reason, like over here, radical 5 times radical 5 is just 5. So I have 3 of the cubed roots of 2, so it's just 2. Can I find, is there 3 of anything in 12? It'd be a 2, 2, and 3. So in this case, this one's done. Okay. Now, here's where things, this last one here on this page, you're my advanced class. I'm going to make you guys try to do this the way that I rationalize things. Is it different? It's a fifth root right here? Okay. Okay. All right. Thank you for telling me that. That way I'm not totally confusing you. All right, so the fifth root of that. Now, so how many do I need? I need 5. How many do you already have? I have 2. I have x squared. Technically, I have 2 of them already. How many more do I need? I need 3. 3 and 2 make 5. If I want to do the fifth root. Now, my regular classes, when I teach this, I don't teach this method because for them it's going to be over their heads. For them, they would take, there's only one of these right now, they would do 4 more x squareds. Then they'd have to figure it out, and then they'd end up simplifying at the end. It is, but they understand that concept. For them, a lot of them can't rationalize through this, that here's 2 x's, I need 3 more of them to give me the 5 total. They just don't get it. They don't get it. So the top fifth root of x cubed. 6 times the fifth root of x cubed all over. It's just x. What did you get 5 of? You got 5 of the x's. So you just have an x. Yeah, so that's the way I do them, and I think you guys should be able to follow that. Should, with practice. With practice. Let's look at another one. I could see the look on his face. Just hang with me, okay? We'll do more. I promise. Do you guys not have this one on there?
Yes, we do.
My notes changed from Thanksgiving time apparently to to when I did them in the spring and changed them like that. Sorry, we'll jump to this. You have it. Right? Yeah, it's on this. Okay, so on this one, what are you going to do first? Simplify. Good. So you're going to end up with the cubed root of 27. Then what? So where's the x go? The x is underneath. And a y squared's on top. Okay. So simplify your fractions. Then I want you to simplify the radicals. Can you do the cubed root of 27? That's 3. Cubed root of y squared? I gotta leave it in. On the bottom, can I do anything with the cubed root of x? No. So right now I have an x. I need it to become an x cubed for it to go away, right? So I'm going to multiply it by the cubed root of x squared. That way this gives me x cubed, which makes that go away then. So on the top, we have 3 times the cubed root of, I'm going to write it just alphabetical order, because otherwise it'll drive me crazy. But it's not wrong otherwise. All over just x. It's not bad. It throws people because it's not quite the same as square roots. Homework's on the back of your notes. Yeah. Let's do this one. Because this one, we'll see. I think we'll be all right. We'll see. So on this one, can I simplify first? 5 over 2? No. No. The x's, though, okay, so let's kind of write what we got going here. We have 4th roots. The 5 and the 2 I can't do anything with. X's become x squared on the top. And the y's? y on the bottom. All right, so I simplified my fraction. Can I simplify any of the radicals? No. I can't do the 4th root of 5, and I don't have 4 x's to come out. I can't do anything there. Okay, so that's the next thing I'm looking for. But I can't leave the radical on the bottom. So I need to multiply top and bottom by the 4th root of what? I agree with the y cubed. It's 8. It is 8. Right now, this is 2 to the 1st. I need 2 to the 4th. So how many are you missing? 3 of them, and 2 to the 3rd is 8. So let's go ahead and multiply and see what we get here. Make sure we're still good all the way through. Yes. Yep. So we have the 4th root of 5 times 8. It's 40. We have x squared y cubed all over, what's left on the bottom? 2y. Doing okay? You guys did better with this than I thought you would, so that's good. Yeah. Most people, it's like a 3-day process to get them to do that. Okay. Yeah, as far as that one goes. Yeah, that's it. As long as you're simplifying first, the end part, usually there's not much to do with it. Yes, you can. All right, guys, homework for tonight then. It is right there, 371, 12 to 51 multiples of 3. But if you look at the problems I put on there, I only put the multiples of 3 on your paper. Thanks, you too, hon. Yeah, if you look at the back of your notes, I only put the multiples of 3 on there. So do all of them on there. Yeah.